This video considers great circle distances, that is, the shortest distance between any two places on the surface of the Earth. Now, so far, we have only considered the distance between two places that are aligned either on a parallel of latitude or on a meridian of longitude. Now, it can be shown that by placing a string on a globe and pulling it as tight as possible, that the shortest route between any two points on the globe is part of the great circle joining the points. You might like to check this for 2 points that are on the same parallel of latitude. The shortest distance is not simply travelling east or west. This is the formula which gives the angle subtended at the centre of the Earth by any 2 points on its surface. When using this formula, it's important that latitudes that are south of the equator are entered as negative. The shortest distance between any 2 points on the Earth's surface can be found by applying the great circle formula to find the angle subtended at the Earth's centre, and then using it in either of the formulas distance equals 2 pi r times theta over 360 or distance equals 60 theta, depending on whether you want the answer in kilometres or nautical miles. The worked example shows the distance between Cairo and Brisbane. Now, the formula is not as formidable as it appears. It's just a sheep in wolf's clothing. We're given all the latitudes, and the only tricky thing is finding the longitude difference. This is sometimes best worked out using a bird's eye plan view diagram. Cairo is 31 degrees east of the prime meridian, and Brisbane is 153 degrees east of the prime meridian. To find the longitude difference in this case, we'll need to subtract the two longitudes. 153 degrees minus 31 degrees equals 122 degrees. Now we pop it into the formula along with the latitude information. Remember that southern latitudes are entered as negative, and then we let our calculator do the work to find out theta. Now this of course is not the distance, and to find the distance we need to substitute it into the formula d equals 60 theta to find the distance in nautical miles. It's probably best if we do a couple of these examples for ourselves. The first is the distance between Rome and Melbourne. Here's the formula. We have the latitudes, but we need to find out the longitude difference, which can be found using a plan view. Rome is 8 degrees east of the prime meridian, and Melbourne is 145 degrees east of the prime meridian. This is the angle that we need, and it can be found by subtracting the two longitudes. The longitude difference is 137 degrees. Put all the information into the formula, remembering to enter the southern latitudes as negative. This particular calculation is one which works well if it's done all as one big long string on your calculator, and in fact I recommend doing it that way because it may save you from errors. You'll get a value for the cos of theta, and then you'll use the inverse cos to find out that theta is equal to 147.28 degrees. This is the angle subtended at the Earth's centre when a journey is made from Rome to Melbourne. To find the distance, we use the arc length formula. D equals 2 pi r times theta over 360 because we want to get the answer in kilometres. Find the answer equals 16,377 kilometres. Our final challenge involves finding the time taken to fly from Sydney to Los Angeles, and the first thing that you should notice in this question is that the speed of the jet was given to you in knots. If the speed is in knots, then the distance should be worked in nautical miles, but that'll come later in our workings. We start with the formula. We know the latitudes, and the longitude difference can be found with a diagram. Sydney is at 151 degrees east, and Los Angeles is 118 degrees west. The angle that we need is marked in red. In this case, it is found by adding together the two longitudes and subtracting them from 360 degrees. The longitude difference is 91 degrees. Put it in the formula together with the latitude information, and we can calculate theta. If you've got some skill in programming or in spreadsheets, then you could make yourself a handy app that will help you do these sorts of calculations. We want the distance in nautical miles, so we're going to use d equals 60 theta. Theta equals 108.95 degrees. We can find the distance, but we were asked to find the travel time. Now, time equals distance divided by speed. The distance was 6,536 nautical miles divided by the speed, 310 knots. When you get your answer, convert the decimal hours into hours and minutes. You can do this by writing down the full number of hours, that's 21 hours. Then you get the remaining decimal part and multiply it by 60. 60 times 0.08 is equal to 5 minutes.